Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, and I am here to present my analysis project on evaluation of classification algorithm with solution to class imbalance problem on zakat distribution dataset. An imbalanced dataset refers to a situation where one of the classes has a smaller numbers of samples compared to the number of samples in the other class. Zakat distribution with the Imbalance dataset was utilized for the evaluation class imbalance dataset. The zakat distribution dataset shows an imbalance of samples between eligible and not eligible students who zakat has assisted. The information was gathered for UiTM Place students who apply the zakat. The number of instances in the minority class is 68, which are not eligible, and the number of instances in the majority class is 1,881, which are eligible to receive the zakat. In this case, the imbalance ratio is represented, which shows 95.5% for the majority class and only 3.5% for the minority class. The statement indicates a significant over-representation of the majority class in comparison to the minority class. The result highlights the class distribution imbalance in which the majority class dominates the dataset while the minority class is severely underrepresented. Firstly, the lack of true positive detection has a significant impact on prediction performance since the dataset of zakat distribution at UiTM Place occur imbalance problem. The common issue observed in the table is the detection of the not eligible class being poor. This is indicated by non-zero values in the false negative cells, which represent cases where eligible is incorrectly predicted as not eligible. This means that some instances which should have been classified as not eligible are being misclassified as eligible. The fact that the true positive values are relatively low compared to the false negative values suggests that the models perform poorly in identifying the not eligible class. Secondly, it indicates that the algorithm is not effectively capturing or recognizing the positive instances pattern in characteristic. According to the table, all the algorithm exhibit the relatively high accuracy, which range from approximately 95% to 95.4%. But the precision, recall, F measure, and ROC errors values are all algorithms are zero. Furthermore, if the precision, recall, and F measure are equal to 0, it signifies that the algorithms did not make any true positive prediction, which is the student may not receive amount of zakat. This implies that the algorithm has failed to correctly classify any positive instances, resulting in a false negative. Thirdly, it will impact on prediction performance. This model also exhibits a small number of accurate positive prediction and a greater number of inaccurate negative prediction. The low sensitivity indicated by the low true positive values suggests that these models do not accurately identify positive cases. As a result, the algorithm's ability to predict and classify positive instances in future data may be compromised and perform poorly in correctly predicting instances of the minority class. The study aims to evaluate the performance of the resampling technique, which is synthetic over sampling technique, SMOOTH. This approach aims to enhance the true positive or the detection of the minority class, which in this case is the not eligible class. Next is to identify the best classifier for class imbalance zakat dataset by comparing the classifier's performance. The evaluation is based on various metrics, which include accuracy, precision, recall, F measure, and ROC area. The algorithm considered in the study include logistic equation, decision tree, and the random forest. After applying SMOOTH to address the class imbalance in the dataset, the confusion matrices in the table have shown improvement in detecting the non-eligible class, as indicated by the increase in true positive values for the class. These increased positive values show that after being trained with smooth augmented data, the models have grown more adept at recognizing the not eligible class. Next, The table displays the evaluation metrics for the logistic regression, decision tree, and random forest classification algorithm. The improvement indicate that the values of accuracy, precision, recall, F-measure, and ROC area in terms of accurate prediction after applying smooth. The result indicate that random forest consistently perform well across all evaluation metrics after smooth has been implemented. It attained the highest level of accuracy, precision, recall, F-measure, and ROC area. To summarize, this study addressed imbalance dataset using the Zakar distribution dataset and conclude that employing the synthetic minority over sampling technique, which is smooth, effectively resolved the institution's challenges. Various evaluation metrics, including accuracy, precision, recall, F-measure, and ROC area, were utilized to compare the performance of different algorithms when smooth was applied. The findings indicate that the random forest algorithm is the most suitable method for managing class imbalance in this scenario. Its demonstrative superior classification performance and effectively handling of imbalanced classes. That's all from me. Thank you for your time and attention.